Agora é o seguinte, a nossa próxima palestrante, ela é Web Developer Relation do Google, e ela vai ser uma parada prática, porque ela vai construir um pequeno compilador aqui. Vocês vão juntos construir um pequeno compilador aqui. Então eu estou bem curioso para ver como vai ser. Quero pedir uma grande salva de palmas para Mariko Kosaka! Bem-vinda!
Whoa, let me say, I have never been welcomed this way. Thank you. Okay, how to be a compiler. Hi, my name is Mariko. I have no idea what that introduction said, so I'm going to say, maybe repeat it again. That's my Twitter handle. That's also my GitHub handle, pretty much everywhere on the internet. That's my Kosamari. I work for Google's Web Developer Relations team, although this is like a new job for me, like 5 months. I was a software engineer making web applications for almost 3 years, and then before that, I was a product manager for that. So, I'm based in New York City. Although I came from Copenhagen to Brazil, I live in New York City. And before I get to that, I said I'm going to talk about compiler. How many of you have written compiler before? How many of you use compiler every day? How many of you use BrazilJS? How many of you use TypeScript? Flow type? All right, cool. So most of you kind of use compiler. So I'm going to talk about why I was interested in compiler, because it's a little unique than you expect. So I'm not a computer science degree. I like to make JavaScript, write fun things with JavaScript. I write web applications. That's how I got into programming. I also like knitting as a hobby. Like knitting, I mean like literally like hand knitting. Oh, it's a little hard to see, but this is me flying to Copenhagen to other work just the last week, like hand knitting. But also, because I'm a programmer and a knitter, I also like to combine code and knitting too. So a few of the projects that I did is a sweaterify, which let you upload. So which let you upload an image of any image you want, and then it will output like what it would look like on the sweater. Very popular in Christmas time. So I've been updating this for 2 years. This is my longest running open source project that I'm actually maintaining. So you know, this Christmas I will have more update. I have like things that I'm thinking about. But also one time, I was interested in making a programming language for knitting. So I wrote a very tiny domain-specific language called 64 stitches, which basically make those patterns on the background by coding, like you write knitting pattern. Because I don't know if you've knit before or knit in American way of pattern. Knitting pattern instruction comes like this. So it says how many stitches you need to cast on, and then a whole bunch of weird thing, and then tells you things. And you learn to read these as a knitter. And to me, it's a lot like code. Like you can see there's like a K repeating. Maybe it's a variable. And then there is a more distinct one that is like K until 2 stitches remaining, repeat from start to the end, repeat 5 times. It's kind of like a loop. So while I was knitting as a hobby, not as like a job coding, I was like, this is a good match for programming language. So I wrote a tiny programming language that let you design patterns, but in the way that you write a pattern. And here's what people made. Here's an invaders game. Here's a skull, of course, cat. And then we had fun with it. So I released this maybe 2 summers ago, and I used a library called PegJS, which let you make your small language and without there's a very small set of grammar that you need to learn from PegJS, and then PegJS will automatically generate the compiler for you. So that was my first attempt, and I was hooked. I was like, this is fun, writing my own language and compiling to JavaScript. Awesome. Next summer, I was walking around in my neighborhood. I went to my favorite bookstore, and I bought this book called Design by Numbers. And Design by Numbers is a book about programming language developed in MIT Media Lab in like way before processing. And it actually became a base of processing. And the premise of this programming language is to teach computer science and programming ideas to the visual learners like artists. So this is the first program you would see in the book. In DBN, it's a language to generate visuals. So there's a paper and pen. Paper 0 means white, 100 means black, and it's only grayscale. And then the lines are defined by XY coordinates, and the 0, 0 point starts from the left bottom. So this is basically saying like grab a white paper, grab a black pen, and then start the line from the 0, 0 XY coordinates to 100, 100 XY coordinates. Oh, by the way, the paper is always 100 by 100 size. So I was like, this is cool, and then flipping through, and it's awesome book if you're interested in those things. Like they will like step by step introduce this idea of the variables, loops, and like how programming language evolves to the full-on language. It's totally awesome. And then like I went to like, oh, this is an MIT project and it's open source. I should go look up. The website still exists. The latest release was 2003, and it says, exciting, you can learn Debian in browser. So I'm like, great, I'm gonna click on this and try this browser level thing. Nope, it's Java, it's applet, it doesn't work anymore. It's like literally like a gray screen and I can't do anything. So I was like, oh man, like I really wanna like use this language, it's like awesome. Oh, I know the kind of language that produce these like visual with paths and lines and colors, SVG. Like, so because I was already interested in making programming language, and I was like, I had this like specifications for language in the book of how this programming language should evolve. And I already had a tool on browser how to like visually express those things. So I was like, take that language, output the SVG. How can I do that? And I was like, I guess I have to make a compiler. So I told you I did make a small language, but I only used library that is very helpful. I had a zero understanding of a compiler, and my image of compiler was this. Like, you basically send whatever the code you wrote to the compiler, and then if the code is really bad, it captured it forever and dead and there and stay there. And like, compiler will never help you to like, solve anything. It's just like a black box that code might die there. And I was like, Also, as I mentioned, I'm not a computer science degree, so I'm like, I've never traversed a binary tree or anything on the coding interview. Like, can I do this? I'm a web developer. So I started with like, well, what if, just like before writing code, let's just try to be a compiler. Like, what's the process that compiler goes through? Because I read the book, and I know what the code should do. So let's do this like thought experiment together. Look at this code, paper 0, pen 100, line 050, 150. Just imagine what kind of visual this code will produce. I'm gonna wait for 5 seconds. And maybe you have a guess, whatever picked the guess. Did you guess this one? How many of you guessed this one? Congratulations, those of you who made it through, you just became a compiler. Really, what compiler is that you have input text, and your brain just did a whole bunch of things, and then made output text, well, output code, in this case, is a visual. So let's think about what just happened in our brain, or like, those of you who didn't guess it, then what your brain was trying to do. So you were given this piece of code. As a human, you can see that these words are separate. So you kind of separate each other, right? And then you classify those things as, like, okay, paper was a word, 0 was a number. And then as we exercised it, we know that the paper word is always followed by 1 number. Pen is followed by 1 number. Line is followed by 4 numbers. So you kind of start to grouping those things and try to see the structure of code. Once that's done, then in your brain, without you thinking, you kind of translate it into kind of human readable expression, right? So in this case, it would be get the white paper, grab a black pen, draw a line in the middle, which is a 50-50 for the y coordinate, and then left to right, which is 0 to 100 for the x coordinate. And this is the compiled result. This is kind of like a executable file when you compile C. Like you can give it to anybody and everybody see the same thing. They don't care what the code was to do it. They will say there's a square paper and there's a line in the middle. You communicate those things. So that process that we went through is exactly the process the computer compiler goes through. So let's go through by code, actually looking at the code. So you have an input text, then there's a 3 steps to get to the output text, which is the black text. So the first step is tokenization, and sometimes it's called the Lexical Analyzer. So you take the input text as a string, and I'm not going to show the JavaScript code. If you want to know like exactly how this code works, I have a sample, but I will explain like what input goes into and what comes out. So ask me any question if you have like a coding question. So you put a string, you pass the string to function Lexical Analyzer. This function turns this string into an array of object. In my case, I just split by white space and then like check if it's number or word, and then classify it. Next step is parsing. And at this parsing stop, you create something called abstract syntax tree. Much like we kind of like parsed it with like, okay, there's a paper and there's like 100 and there's number and things. And then we started to see like, okay, this paper 0 is a 1 chunk and pen 100 is another chunk. Creating an AST is kind of like trying to see the relationship between those tokens. And so this is the input, again, just an array of objects. And then the function goes through those objects and then trying to see, okay, I found a call expression, which is a paper, which is a call for, grab a paper. And then that should be followed by one argument of the number 100. And kind of start to reorganize that data. And I would like to think AST is a map of your code. So you have a bunch of data, you tokenized it, so you have all the points on the map, maybe interest points on your place that you want to visit in Porto Alegre, and then you are trying to see the meanings behind it by drawing the line and planning for your day. So I like to think of that as a map. Next step is transformation. See, this AST that we just created is great for communicating what it is in this design by numbers sphere. We have idea of papers, we have idea of pens, and we have idea of expressing the colors by 0 to 100. So that's perfectly fine. But what we want to get to is SVG. And SVG1, there's no paper element, there's no pen element. Colors are defined from 0 to 255. So you have to kind of tweak it in order to be ready for SVG. So you would go through this object again, and then change that format to something like this. This is what I came up with, a new AST, which starts with tag is SVG, and inside of the SVG tag, I have a body, and inside of that, I have another tag, rectangle, which is for the paper, and then size and color of things. And lastly is the code generation. Now that we have an AST ready, you can go through and create a SVG tag out of it. So that's the basics of the compiler that I wrote for this design by language number, design by number language. Let's see the demo. So I made an interactive REPL. So I have a paper. If I want to say paper is 0, right? 0 in DBN is white. So I'm going to turn the paper to 0. I'm going to make it to 100. And if I have a typo about I forgot if it's line or, let's see how that works. There you go. Okay, so this is really hard to see. So much better. So I made a level. Here is the code that goes into. So it was starting with, this was the default. So I want to change the color of the paper to white. Then I would change it to 0, pen to 100. And then now the color is imported. And every time I change it, it will show you the different steps of tokens that created, AST that created, and transformed AST I created, and then the object generated code, which is literally just appending to this DOM element. And if I have like, I forgot how to say line, then it will throw the errors. So at this point, you might be thinking, well, Mariko, that's great that you made an art project, but like it's not really useful. So let's apply this exercise into something useful. So I asked you all that if you use Babel or not. How many of you heard of AST Explorer? Ooh, this is exciting. So as you may know, and if you don't, that's totally fine. Babel is a compiler for JavaScript. It takes JavaScript and outputs JavaScript. But the JavaScript that you take is a newer version, like ES7, ES 2018 and 17, a newer feature that is not yet supported in browser or environment of your choosing. And then it will output it into ES5 or ES6 or whatever the version that you are targeting to. So in AST Explorer, you can explore what kind of AST those compiler makes. So in this case, I'm looking at the Acron, but you can see the Babel's AST. There's a TypeScript ASP, there's a Flow, and there's a Esprima. So let's see Babylon 7. And then let's start with like very simple code. Console log, my favorite line in JavaScript. BrazilJS, right? And as you type, it creates an AST. This is the version of AST that Babel used in the Babel code. You know, I define my own AST based on my preference, but Babel has a set of AST that they use. And you can hover over the things like, you know, oh, console is identifier, or the string is a string literal. And you can start to see, discover what kind of AST Babel is making. But wait, that's not, like, let's not end there. This AST Explorer is awesome that let you write a transform function, the one that I did to transform it to SVG. You can write a transform function, which means you can write a Babel plugin right in the browser. So let's write a Babel plugin. Let's say, I want to say, like, you know, all of my code, any JavaScript that I write, I love emoji. So all the Brazil word should be replaced with Brazil emoji, like, you know, permanently. So let's do that. So I do the type transform, and then selected the Babel v7, and then it gives you kind of like a template code for transform. And then on the right-hand side, it will give you, you know, the output code. So right now, template code is just like replacing all the word order. But let's say transform Brazil emoji. And I hover over to the string, say, OK, so this one is called string literal in Babel AST. So I'm going to copy that. So when visitor is string literal, and pass.node is what's in this data chunk. And in this case, they don't have a name, but they have value, which is the string that I want. So I'm going to do the pass.node.value. And let's say, you know, before I do anything, test it. Let's say, whoa, whoa. So in this case, any string that I put into this input code, say, hello, is turned into whoa, whoa, because I haven't done any fancy stuff yet. So as I was planning, let's make it to a transform to emoji. So let's do pass.node.value again, and then replace with a regex of Brazil global, and then replace it with, oops, double quote, no, single quote, Brazil emoji. And now everything I write, say console log, oops, it's great, import import Alegre Brazil. And then, you know, every time I type Brazil, 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 it just replaces it with emojis. So once you have that, then you just grab this code, go to your, you know, text editor of choosing, and just copy and paste it to make a bubble plugin. So in this case, because Node doesn't support a ECMAScript module imports, so like the example is the export default, but Node doesn't really understand it, and I didn't want to like add another, like I didn't want to do like a bubble, my bubble plugin, so that I can bubble another code. So I was just like, okay, it's easy enough that I'm gonna write exports default. So I changed it a little bit, but literally this like what's in the return is exactly same as the one I did in the REPL. I wrote a very simple package JSON that says like main is index.js and here's the name of the thing. I type npm publish, was it? And then I pushed it this morning. So I have a test.js which has a whole bunch of console log with a bunch of words. So let's test it. And oops. So again, I have test.js that has all of the console log, and the input code has not been emojified yet, or the Brazil word is there. So I am gonna bubble. Bubble. Oops. Plugins. S is important. Transform a Brazil emoji test.js. Bubble's gonna do, ooh, error. Oh, transform. That's my jet lag coming out. Thank you for calling that out. Form. Wait. Good? Yay! So, in this case, because it's generating the code, it's changing the emoji to Unicode code points, and you can't really see if it's actually a Brazil flag emoji or not. So, let's pipe into a node and actually run this output code. And ta-da! You can see the output with emoji. Okay, so let's see how this goes. Cool. And what did I do with my clicker? There we go. So, if you want to look at it, there's npm install bubble plugin transform Brazil emoji. I pushed it. It's totally for demo. Like, I have no linting, no testing at all. I literally pushed it this morning. But it was for me to make a point that it's really easy to start writing bubble plugin and dealing with compilers. And if I can do it, then you can totes do it. Because Jeff knows that last night I was trying to push this thing, and I was like, I don't know why this ES6 import doesn't work. And he was like, yeah, Node doesn't support that. Like, I don't know anything. You can totally write bubble plugin if I can. And that's the point. So Henry Zhou, left pad on Twitter, is a really good friend of mine. He's based in New York, and he comes over to lunch sometime to Google Office, and we talk about what the bubble is doing, and what we from Google Web Developer Relations standpoint, I should like help him. We had this conversation last week. So decorators. Decorators is a new proposed JavaScript syntax that many people hate and many people love it. And everybody's just talking about decorators, decorators, decorators. In Bubble, until recently, there was no decorator transform because nobody wrote it. Nobody wrote, even though it is a very requested feature, nobody thought to write a plugin and transform for decorators. And recently, Bubble project got a Google Summer of Code and Leo scored Summer of Code. So they got a little bit of funding and resources, basically summer intern, to write something. And the intern chose, hey, I want to work on the decorators. So now they finally have a decorators transform. But he was saying that, like, why are we waiting until this, summer program to come around to support this highly requested feature? Why, doesn't community write those things? So now you know how to write a Babel plugin. If you're interested in new feature, like you heard from the talk before, and you want to write a plugin, you should totally do it. But, it's not limited to what you do with JavaScript spec and what's proposed, right? You should have fun with compiler. So here's my suggestion. You can totally write a Babel plugin to write a JavaScript in Portuguese, right? I'm a Japanese, and like constantly frustrates me that why can't I write JavaScript in Japanese? Like, I write my comment in Japanese, and I transform with Babel anyway. Like, why can't I just like do the function into kansu, right? So maybe you might want to do that. Actually, somebody in Sweden did that. So there's a Fika script, which let you write a JavaScript in Swedish. Another one that's fun one, because I like emoji, is the emoji code. Lets you write code in emoji. And it doesn't have to be text. There is a programming language called Piet. And I don't know if you know Piet Mondrian, which is a famous painter. So in this programming language, picture is your code. And there's a certain way to interpret colors and orders of the picture in order to get your code, output code going. So creativity interest, when I started writing compiler, was feeling like this, that like, I don't really know about compilers, and it's really scary, and I'm not sure about this. But now I feel like, compiler's a box of fun. It's like, you should totally go hang out with compilers and have fun. And on top of that, from learning how to make compiler, I learned how to be a better software engineer. And I want to share 3 points. First of all, start like Lexical Analyzer. I have a numerous time that started a project and like, I don't know how to do this like a master grand plan, so I'm not going to do it. And then just like put it off for 2 months. Just start like Lexical Analyzer and Tokenizer. Just like see the chunk of stuff that you can see already and start from there. And then just like worry about the rest of it in the later stage. It's okay to have unfamiliar things. Another one is a good parser. Like, don't be jerk with bad error message. This is not just for the error message you write in your code, but also with your coworkers. So I, as a relatively new programmer coming into industry, I ask a lot of questions. And sometimes I'm like, I don't know why this doesn't work. And then, the senior engineer says like, yeah, that wouldn't work. And that's not helpful. Like you may be able to say like, yeah, that wouldn't work. Like you don't have to tell me step by step how to fix it, but you might be like say like, yeah, that doesn't work. Maybe you should Google this and that, or maybe you should read this like documentation. Like give the hint a little bit. Elm, the programming language, is applying this principle. And they have a blog post about compiler error for humans. So when you get a compiler error in Elm, the language, it will tell you that there's an error, and this might be the solution. You might want to look at this part. It's really helpful. And lastly, the bridge the gap of like transformer. So context is everything. Much like the AST that we wrote first, needed to be transformed into SVG because there's no idea existing of like the idea of SVG and SVG element doesn't exist in one AST. Like the software I write in United States may not translate to the idea and customs in Brazil. So when you write a software for many audiences, you should think about the context always. And you should find good transformer in your coworkers who can translate like, oh yeah, the user sign up that doesn't work for such and such regions, that's because this and that. Those people are good transformers and very important in your project. So, in my conclusion, being compiler, not just writing, but being compiler is awesome, and you should totally do it. If you're interested in the code part of it, I have a blog post with all of the code snippets to do that design by numbers compilers. It is published as a Creative Commons license, and I am accepting all of the translations. I don't have Portuguese yet, so if you want to translate it to like share with, you can just post it on your Portuguese versions on your blog post and just tell me the link and I will link it to you. Like, please help do it. And speaking of translation, at work, sometimes I write contents for it and I deploy the site called developers.google.com/web. Here, this is the place where all of my teams are putting all of the newest information to. This code, entire document, is hosted on GitHub, and we have Brazilian Portuguese versions of it, although not all of the articles are translated. If you're interested in contributing to the open source project by translating a documentation, you're more than welcome to. And if you have any question about this, just ping me and I will help you through. If you haven't guessed it, I really like to draw things and like go into like handy little things to explain tech content. So those are the few of the drawings that I made. And I'm fielding the ideas of like what you want to know. What should I explain in drawing? Like, tell me what is confusing to you. That's my job. Please tell me. And if you tell me at the conference today, I have stickers for you. So please come say hi. Thank you very much.